In this video, we'll be talking about basic polynomial division. So how do we divide a polynomial by a monomial? That's where we're going to start with this. The good news is that you actually have already done this, but you did it in the exponents unit. You only did monomial divided by monomial. Now we're going to add on some more terms. So the basic structure over here to the right, we're going to fill in the blanks here first. So again, we're using exponent rules. So when you're dividing, you blank the coefficients. Well, coefficients are the number portion. We just do the typical operation, whatever it is. So we're going to divide the coefficients, and then in polynomial and monomial division, the exponents, when they have a common base, so if we have x squared over x, we subtract the exponents. So that's just a quick review from our exponents unit, and that's really the rules that we're going to follow. The difference is, as you can see over here on the left in our box, if we're looking at this trinomial divided by this monomial, we're simply going to take each term of the polynomial, and we're going to divide every single one of them by the monomial. So notice how these are all the same. And then we just reduce using exponent rules. So let's take a look at example 1. We're taking 27x to the third y plus 18x to the third y squared z, all of that divided by 3xy. So you can do one of two things. You can either rewrite this into the individual fractions like they did above, or I'm just going to take each term and divide underneath it the 3xy. And now we just simply reduce. So 27 divided by 3 is 9. X cubed divided by x is x squared. Our y's here cancel. And then it's plus 18 divided by 3 is 6. X squared would be left, y would be left, and the z remains unchanged. So that's example 1. Let's do one more together just to show the difference here. In this case, you're using the fraction bar instead of the division symbol. So again, you can rewrite it into 3 separate fractions. I'm just going to cheat a little bit and put the xy under each individual term and pretend that they're separate, and now reduce. So numerically, we don't have any numbers to divide, so all of the coefficients will stay the same. When we subtract our exponents in the first term, the only thing left is a y. Second term, the x and the y cancel. And the third term, the x stays and the y cancels. All right. And then we've got one more example to try. How about you pause the video and try that on your own? Come back and check in a second. So again, you can simply write the denominator under each term, or if you don't need to, you don't have to show that step, but we are going to divide each term by 5x squared y. So the first term, we've got a y squared left. Second term is negative 2x squared y when we subtract our exponents. And then finally, we've got 3, and that's it. There's nothing else left in that last term. Note that we do want these to be simplified, so chances are there aren't going to be any like terms when you're done. If we look at our 3 final answers, everything has kind of a hodgepodge of x's and y's attached to it, but you do want to be checking to make sure that that is fully reduced. All right, now you are going to try the 4 examples on the back, and then in a moment you can come back to the video and check your work. All right, so on the back, I'll zoom this in so you can see those first 2 examples. Again, notice in the first one, I did put the term under each term on top, but in the second one, I just simply divided. And then if we scroll down here, just to quickly double check, but this is polynomial division when we're simply dividing by a monomial or just one term.